Well, a warm welcome to Isifundi and to another episode of this Bite-Sized Corrosion series where we are celebrating women in corrosion and in engineering. My name is Vanessa Seeley Fisher, and it is my great pleasure to host today's session. In every session of Bite-Sized Corrosion, we try to look at another aspect of corrosion-related information and break it down into palatable nuggets, if you like. So here's to another incredible woman in the corrosion engineering space. Today, I'm delighted to welcome Dr. Janet Cotton to the microphone. Janet is the founder and managing director of 180 Materials Testing, where material failure analyses and commercial research are amongst their many offerings. And I'm really looking forward to learning a whole lot more about Janet and what she does today. So welcome, Janet.
Thank you, Vanessa. Thank you for having me on the show.
It's a pleasure. Now, Janet, you've had an incredible career in materials and corrosion engineering, spanning over 2 decades, am I allowed to say? What initially inspired you to pursue this field?
Well, I have to say that I was one of those kids that was always interested in all things technical. So I had a chemistry set when I was about 12. I saved up for a microscope and would collect things from the garden to investigate under the microscope. And when it got to my matric year, I'd actually registered and signed up for an accounting degree. And I had a very good friend from yachting, from competitive yachting, because I've been involved in competitive yachting my whole life. And he was studying electrical engineering, and we would chat. And the more I chatted to him, the more I was just absolutely fascinated and bowled over that you could take physics and maths to this whole new level, that there could be a career that involved, using these problem-solving skills and all of these exciting things as a job. And I started to investigate the various fields of engineering. And I went to an engineering open day at UCT and had a look at chemical engineering. It didn't resonate all that well with me. Mechanical engineering resonated to a degree. And then I walked into the materials engineering department at UCT. And I remember looking at all the electron microscope images that were collaged on the wall. And I thought, what is this? And then they took us into the electron microscope room, and we could see these images of all sorts of things. And this just took, my microscopy interest from when I was much younger to a totally different level. But what excited me the most was that you could work out the properties of engineering materials by looking at them under a microscope, and that actually the properties of a material could be designed by way of heat treatment or by forming or by processing, essentially. So the process property performance triangle of Sir Michael Ashby, was presented to us. And that really excited me, that materials had properties and that their microstructure was a sort of guide as to what they were. And I fell in love. I have to say that materials engineering has been the greatest love of my life. And yeah, I immediately changed my application to materials engineering, and I've never looked back. Yes, my affinity to be good at accounting has served me well in running my own business, but I certainly would not be able to wake up with the excitement that I wake up every morning for this calling, I call it, as a metallurgist and materials engineer.
That is so wonderful to hear and exciting. I also briefly looked at the accounting and went, no, we'll leave the numbers for other people. Now, you've alluded to the fact that accounting has served you well. What motivated you to actually start your own business and become a businesswoman as opposed to, say, staying in research or industry?
Yeah, so, I finished my bachelor's degree. I went on to postgrad. I started with a master's degree. I was invited to upgrade to a PhD, which I gratefully accepted. It all seemed very crazy at the time. When you're very young, these decisions seem very big. And when I look back now, they were actually very small decisions. So I left UCT. Well, I found myself at 24 with a PhD in materials engineering and a bit confused as to what to do with my life. So they offered me 2 years postdoctoral fellowship. So I thought, well, this would be a great test to see if I want to be an academic. There was a huge teaching component to being a postdoc and also running research programs. I thoroughly enjoyed it, the 2 years postdoc, but I just couldn't reconcile with myself that I would make a career out of teaching engineering if I'd never practiced as an engineer. For me,
Right.
that was something I wasn't able to reconcile. I know that there are people
Mhm.
that's their calling and they're fine with that, but I wanted to just dive into the industry, and for all of its messiness and whatever challenges came my way, I was intrigued and wanted to be exposed to them. Coupled with that, at the time, many people from the industry would just rock up at UCT with corroded bolts and rusted this and that, and I'm focusing on corrosion failures, but
Mm.
all sorts of failures really, but
Mm.
very often corrosion failures, and especially in the marine industry, corrosion is a big
Yes.
problem. So I saw a business in this, and I thought
Mhm.
there is a sincere and serious need that people from the industry, fabricators, industry players, were willing to drive to UCT and say, please help me solve this problem. And I thought,
Yeah.
well, I wonder how many other problems exist in the industry like this. And I wrote a business plan and then became sort of impassioned by this business plan the same way I became impassioned by registering for engineering. And I turned down the offer for a position at UCT as a lecturer. And I launched my business on the 1st of April 2002. And just as signing up for engineering in 1992 was hugely intimidating, I was one of 8 women with an intake of 100 or so students,
Mhm.
all being male. So was launching the company. It was
Mm.
the same sort of, you fall in love with the concept and then there's the reality. But I had to remind myself that this was the reality I was seeking to have an experience of, for better or for worse.
And I think it's been for better. And I know the industry has been well served by your company and that you are solving problems. And corrosion being corrosion, nothing's the same twice over. So I'm sure it's very, very interesting.
Yes, I think one of the things that I love about materials engineering is that materials touches so many other fields of engineering and also other industry
Mhm.
sectors, like insurance, legal, underwriting, and so on. Materials engineering is so commercially relevant across so many different levels that no two cases are the same, as you say, whether it's even if it's on a scientific basis, they're not the same, but the application and the reason for the investigation or the problem or how you apply the solution is always different.
That is so interesting. Now, I know when we were chatting before we came on air, you mentioned that one interesting field for you has become the food industry. And that struck me as quite something because when I tend to think of corrosion, I tend to think of big structures, pipelines, fuel and gas, buildings, those sorts of things. And
Yeah.
food kind of struck me between the eyes. So please share some of what you found have been corrosion concerns and material concerns.
Yes, so in Cape Town, as I was saying to you, we have a big winemaking industry, and as Cape Townians, I think it's a staple part of our diet. But we have a big wine industry and also juice, bottling, and food and beverage industry, breweries, for example. And one of the problems that I'm seeing in the industry is, as I think, you share my view that we are losing the technical know-how around materials engineering.
Mhm.
It's a dwindling
Yeah.
profession in some ways. We're suffering the brain drain. That there are not so many schools where you can study materials engineering anymore.
Mhm.
So there are blind sides that are
Mhm.
becoming more and more relevant in the industry across the board. And food and beverage is one of them. And I'm shocked and horrified to find out that people do not understand how important it is to pickle and passivate stainless steel.
Yes.
Just a simple concept like pickling and
Mm.
passivation of stainless steel. Suddenly, we've decided in the industry that to just skip that step, it's not
Mm.
required.
Mm.
And that just reflects a total lack of consideration of materials engineering and metallurgy, and that is a concern and a threat to this industry sector. So all breweries, all wineries involve a huge amount of austenitic stainless steel and sometimes duplex stainless steel, depending on the application. And to make use of these expensive materials for corrosion purposes and to leave out the pickling and passivation
The key
is
stage,
just
yeah.
absolutely crazy. And it's a reflection of the lack of skills and understanding in the materials engineering space.
And allied with that is the lack of understanding not only of the ramifications of leaving out the significant effect, but also the longer term. You can't sell your wine if it's got rust in it. You can't package juice if it's gone off because of the rust.
Absolutely. And even with canneries where we're not necessarily dealing with pickling and passivation, but a seam weld that has not been correctly effected can result in corrosion. Improper application of the lacquer on the inside of the can also result in corrosion. And that even extends beyond food and beverage, but to cosmetics. If you think about your aerosol cans for deodorant and so on. So yes, lots of corrosion issues in very unexpected places.
And how do you think we can resolve this? Because I think you've correctly identified that we are lacking in the basic understanding in so many fields of the important foundations within those sectors. So in the winemaking industry or in the food industry, the steels, the expensive steels, actually need this critical additional step. How do we go back and re-educate that industry? Have you got any ideas?
Well, one of my ideas has been launching the Root Cause Analysis Conference.
Right.
And it's the Root Cause Analysis Africa Conference. So I'm wanting to draw on interest from the whole continent.
Right.
And my approach might seem a little bit strange, but it comes down to whose pocket is it going to hurt when the materials go wrong?
Right.
And largely it's the underwriters or the asset owners, or both. So that there'll be an asset owner, somebody like SA Breweries who owns a plant, and they own that asset and rely on it to produce product on an hourly basis. And they are also insured. So underwriters have an interest in the materials performing, but they have not yet necessarily joined those dots. So the purpose of the Root Cause Analysis Africa Conference is to bring the drama to the stage and to indicate to underwriters and asset care owners who are very often owned and run by accountants, unfortunately.
Yes, you've tied it all together.
And to say, just taking a small amount of time out to consider the materials of construction, whether it's in your maintenance strategy, whether it's in your, initial capital projects, how you approach a new capital project, what QC procedures you put in place to have longevity of the asset, and for underwriters to also have their risk mitigated. So one of the first cases I worked on when I started my company, I still had a dial-up modem. I don't know if you remember. Yes. What that was. People didn't have an internet presence. To have a website was quite modern in 2002 for South Africa. So I pulled out the yellow pages and I started at A and ended at Z and did a bit of cold calling. And I found myself at SA Breweries in Newlands. And I've spoken about this case many times. And they had a hot water plant, which they had installed. So it was a hot water feed line that ran at 85 degrees C, fabricated out of austenitic stainless steel 304, AISI 304 stainless steel. And the life expectancy, so, the calculations that the accountants had done, was that this fabrication, which was substantial, would last 20 years. And they ended up only receiving 5 years life out of the pipe system. And the reason is obvious for us as corrosion engineers: stress corrosion cracking, active chlorides, 85 degrees C water, it was conditions. Normal potable water. It was never going to survive 20 years. And if somebody had just asked a question like that,
Mhm.
at the investment decision, the answer would have been you cannot use austenitic stainless steel. It's never going to last 20 years. So
Yes.
you might get 5 years life, which is what they did. And the whole place was leaking, like sort of creating a massive hygiene problem for them and a throughput problem for them. On my recommendation, they replaced it with SAF 2205, duplex stainless steel at the
Yeah.
time, very new material in the market, very few people willing to fabricate with it.
Hmm.
And it's still running.
Oh,
And I
wow.
started my business 23 years ago. So just by choosing the right material, the
Yes.
accountants are happy and the underwriters are happy. And that's
Mhm.
the message we want to bring forward with the Root Cause Africa conference, is there's this world that can save you money, and it's called materials engineering, and it's called risk mitigation and corrosion prevention.
Wow, that's excellent. And it's interesting that you have found a way to get into that insurance sector because very often the underwriting personnel are not technical engineering minded or certainly trained. And I would imagine that for many of them, they hear the terms root cause analysis and they go, well, that's not for us. So I'm intrigued how you market to them so that they want to come to learn for their benefit.
Yes. So what I've been doing is talking about the ecosystem of financiers,
Right.
underwriters, insurance professionals, loss adjusters, legal professionals, and engineers, and
Mm.
saying that this ecosystem often gets activated, but it gets activated when there's a dramatic failure. Again, I can't speak about it because I have before, and we've written newsletters on the subject. But you may remember the Darling Cellars tragedy, where millions of liters of wine was lost because one tank fell over, created a domino effect,
Oh
and
God,
many tanks fell over and they lost the
damage.
wine. Now, in that tragedy, let's call it a tragedy, immediately underwriters, financiers, the people who financed the construction or development of that tank farm, the underwriters are talking, legal professionals are being drawn in, loss
Mm.
adjusters are being drawn in, and then they all sit around and say, well, what do we do? Okay, let's get a materials engineer to figure out what went wrong here. The better thing to do is before you start manufacturing the tanks is to say, let's get the materials engineer into this conversation so that we can be sure that this asset will give us the life we are looking for and that we mitigate our risk. I
Mhm.
recently read a book on my way to Ghana. It stuck out at me. It's a South African player in the market named Antonio, and his surname escapes me, but he wrote a book about his journey around oxy addiction due to a terrible motorbike accident that he had. But he said in his work as an underwriter that he actually refused to underwrite certain food and beverage plants because he wasn't able to quantify the risk. There was
Yeah.
all these
Mhm.
machines and materials, and there were things that he couldn't understand. So he chose to not engage in that market. So, this whole intersection between corrosion failure and the importance to loss adjusters and underwriters, insurers, I think is something I'm trying. My vision is to join those dots to create a robust Africa as we industrialize as a continent.
And I think that's amazing to hear, and I congratulate you on that, and I'll keep my eyes open with great interest. Just moving a little further away, perhaps from the food sector, I know that your research and investigations have cross sections in all sorts of sectors.
Yeah.
But do you also undertake fundamental research within your company or as an individual? And if so, do you collaborate with the universities? And if not, do you think it's something that universities should be focusing on a little bit more?
You're probably asking the wrong person, and you know me to be a very straightforward person. I think certainly the model overseas is that universities and industry engage.
Mm.
And there are departments at certain universities who do it extremely well. So, I'm just such an admirer of Professor Cyril O'Connor, who used to be the Dean of Engineering at UCT. And before that, he was the head of Department of Chemical Engineering. And he transformed the model of how a university should engage with industry dramatically. And there isn't time to go into that. But his department, he's retired now and he's an honorary professor, but He's done a lot of succession planning, and certainly his model is a picture of how the university could engage with industry extremely successfully. The problem that we have is there's something called the IP department at all universities, and they're just commercially relevant. Their concepts and their view on IP ownership is commercially relevant, and nobody wants to engage on that basis and have to sign literally a bond document before you can receive some simple answers to a simple problem. And that's made people not want to work with them. It's made me not want to work with certain universities because, we can't all fight about the billions we're going to make in the future when we haven't even started the project. So I think the universities need to modernize their view on that aspect. And I'm sure in time they will follow, international trends.
And that'll be so encouraging when we start to see that growth, because we do need some more research in understanding how materials work and how materials that are being created, manufactured outside of the universities, but how they're performing. And I think universities are the right place to do that fundamental research. And it would be good to have them coming back into, if I can say, some more of the real world, making their research relevant.
I think students want that as well. Certainly for me, I was very lucky. My PhD was on the development of chromonite for Columbus Stainless off the back of their success of 3CR12. So I felt like I was contributing to industry during my postgraduate studies. And I think many engineering students need to feel that they are contributing to industry, specifically in engineering. So yes, I think the universities have to find a way to make that connection and make it so that it's attractive to industry.
Thank you, Janet. As we draw to a close, what keeps you motivated? You clearly have tremendous motivation and passion and excitement for this love affair, which started right back at uni. But what does keep you motivated on a daily basis?
I think right now what is so motivating is seeing the interest grow in the RCA Africa conference, is seeing the connections being made at these various levels. And we last year this year we had a materials engineering company from France come out and attend our conference and present some papers. And they were extremely intrigued at my approach to get this ecosystem talking to each other. And I would like to see Africa industrialize in a robust manner. And it cannot do that without materials engineering expertise. Yeah, we probably don't have time for it, but if you look at the statistics of how many materials engineers are available in America and in Europe to the industry, in Africa, we are nowhere near that. And if we don't solve that problem, we will create another form of colonization where we'll be drawing in those expertise from outside to facilitate our own industrialization. And I'd like to be part of preventing that process. And that's what is keeping me excited at the moment.
Janet, this has been a fascinating discussion, and there is much more to be had, I'm certain. But thank you for sharing some of your story and inspiring all of us to get excited about materials, their corrosion, but actually solving the corrosion challenges. And I'm certain that our audience has enjoyed this discussion just as much as I have. So thank you for giving us some more food for thought in terms of corrosion and combating it. Thank you.
Thank you.